in social. An introduction to statistics, econometrics, and big data. This workshop is basically organized by the Jindal Center for the Global South and Jammu and Kashmir Economic Association. The objective of this workshop is to introduce the researchers, faculty, and early stage social sciences professionals to empirical methods in social science by focusing on its three key foundations, that is statistics, econometrics, and the emerging of big data, by using an optimal mix of theory and practical applications. Moving on further, ladies and gentlemen, I am delighted to announce that Dr. Jasmeet Kaur Lamba, a distinguished professor and consultant, will be joining us today as a speaker for this online international workshop. Before ma'am start, let me give you a brief about ma'am profile. Dr. Lamba is currently a professor and an associate dean at OP Jindal Global University. She brings a wealth of experience in macroeconomics, data analytics, and financial modeling, with previous associations with prestigious institutions such as Collin College, Texas, AM University, Institute de Mines School of Business, and Symbiosis International University, among the others. With a PhD in econometrics, Dr. Lamba is proficient in business analysis tools like NIME, SPSS, eViews, and Smart PLS, along with the ERP systems. Her knowledge extends to cryptocurrency and digitally evolving financial markets, making her insight invaluable for both education and research. Dr. Lamba's research, published in renowned Scopus and Index Journal, spans diverse areas including sustainable development, climate change, and economic growth. As Vice President of the Academy for Global Business Advancement North India chapter, she has also been recognized for her leadership and contribution to academia. Her presence at the workshop promises to inspire and provide invaluable knowledge to all the participants present here. We warmly welcome Dr. Lamba and look forward to her insightful session during the workshop. Thank you so much for coming, ma'am, and over to you.
Great. Thank you so much, Shivangi. This was an elaborated introduction. Thank you. I appreciate your presence as well. And I also thank Dr. Firdaus Malik, of course. Without his initiation, I believe this kind of participation level and this kind of a workshop is something, I don't think so that normally people organize. So this is something, a great initiative that he has taken for sure. And I would now like to welcome all the participants as well. I don't know how many numbers are there, but I think they're above 80 or something. It's a huge number of participants. But yes, I will try and justify the fact that we will try and learn online. So today we will learn about, is there anything else, Shivangi? Do you want me to wait a minute or then just simply start?
No, ma'am. I think we have 100+ people, so we can definitely start the session.
Oh, great. All right. Sure. Thank you. Thank you so much, Shivangi. So am I audible to everybody? Shivangi, you can let me know, please.
Yes, ma'am, you're audible.
Yes, great. Okay. So thank you. Thank you so much. Okay. So let's start with something as basic as regression analysis. I'm sure since last few days, you all have been hearing the word regression and correlation a lot. So that's what we are going to deal with at the moment. Some basics of it. And then we will move on with the software known as JASP. We call it JASP. And currently there is the 19th version, which is available for you all. I hope most of you must have downloaded as well. So we will come to the software, but let's understand the problem that we are dealing with today. So after learning about correlation analysis, correlation is basically in between variables X and Y. Okay. We are not dwelling into rank correlation much, but we are talking about Pearson's correlation. So Pearson's correlation, as you all are aware, is under root and square root and raised to the power 2. The formula is combined of these three parameters, and then we correlate two variables with each other, or as we call it in data analytics, we call them parameters. Okay. Variables or parameters or covariates. It could be anything, but it all means the same. Okay. Then we come to regression analysis. In regression, of course, the word itself tells you it regresses, okay, from one basic parameter to another. So that means in regression, I'm sure you all are aware of it, that we have one dependent factor or variable, and we can have one or more independent factors. And we try and analyze, or we try and find out how much my dependent factor is depending upon these independent factors, right? Now, the problem is not with the dependent factor. Dependent factor is always one. Remember, for one dependent factor, there's always one regression analysis. But independent factors can be many. And that's where the problem starts. Sometimes we are all aware of, I think most of us are econometrics and economics. We have some knowledge about it. So what happens is when there are more factors involved, there is a problem of overlapping, or let's say some things might be overlapped or just missed out or counted twice or thrice, or could be similar attributes. Okay. But then these are independent factors. How can they be similar? There are times when we come to know that there is similarity in between independent factors. And that's where our regression analysis goes incorrect. Or it goes vague. I cannot rely on that kind of a regression analysis wherein the independent factors are correlated with each other. They shouldn't be correlated. That's the logic behind today's lecture. This kind of intercorrelation between independent factors is studied under two concepts. These concepts are known as heteroskedasticity. I know pronunciation might take a while to grasp, but trust me, while you practice more and more, you will understand heteroskedasticity. Okay. Like homogeneity is there, we know homogeneous factors. They are as it is similar to each other, that's fine. But herein the problem is that due to standard deviation, the presence of standard deviation in any data set, the factors are away from the trend line. Many factors are, or many cells are away from the trend line. That's where heteroskedasticity is present. Okay. I'll show you all. I'll just explaining in detail, but I will show you all how it is seen and recognized. Now, heteroskedasticity is the conceptual problem, but the actual problem is multicollinearity. Now, I'm sure we are all aware of linear regression. What all we are doing till now, statistics or econometrics, I'm not going till big data. I'm sticking to statistics and econometrics. When we talk about these two parameters, we talk about linear regression. Okay? Linear regression has a simple equation. When we talk about that equation, linearity, that means my independent factors are independent. But the problem is that my independent factors are also correlated, and that is multicollinearity. They are not supposed to be correlated. And these two problems can give you wrong interpretations, can give your regression analysis some other valuation which is not required. So in order to study these two basic problems, we will try and analyze these two problems through JASP. We will try and understand how do we find out whether a data set has multicollinearity and heteroskedasticity or not. Okay. There are possible ways of doing it through Excel sheets also, but Excel itself is very limited. And that's the reason we use softwares. And I'm sure you guys are already learning about EViews and everything. So I am quite sure that you are well versed with why are we using softwares. So let's move on. Shivangi, can I share my presentation?
Yeah, ma'am, I was about to say the same thing, that if you have any presentation, please share the screen.
Absolutely. Yes, yes, yes. I am. Do you want me to share the entire screen so that
Yes, you
or
can
maybe
share.
current?
Yeah,
Yeah, entire. Okay. I'll share the entire screen so that when I'm shifting screens, it is easier for them to understand. Do let me know if whenever I'm shifting screens and whether or not participants are able to see or not.
Sure, ma'am.
Currently, is my presentation visible?
Yes, ma'am, it's visible. You can go to the slide. Yeah, perfect, perfect.
Perfect. All right, great. So I'll break the word for all of you. Heteroskedasticity. Okay. Hetero means different, whereas we are talking about they're not different, right? And multicollinearity in regression analysis. This is what we learned today through JAS. But let's understand the basic meaning first. So, introduction to heteroskedasticity first. It refers to a situation where the observations are not constant. Okay. That means there are errors, variance of errors lying in my data set. Now, there is a possibility wherein you all might think that, uh, but we do P test, we do the chi-square, we check with the P value also, then why we perform the F test also. Yes, despite of all that, there is a possibility that there is still some heteroskedasticity present. Some error variance is always there. If you remember the regression equation, it is A plus BX1 plus E, small e. That error term is always present. Till the time period this equation will have an error term, there will always be a possibility of heteroskedasticity. Okay. So in order to make a proper model wherein there are no questionable points on your data set, we must always check with heteroskedasticity. Okay. And JASP is a freely available software. Earlier, I was planning with the analytical solver, but solver is more into data mining. Maybe sometime later, if Dr. Malik plans, we can talk about that too. But today, let's talk about JASP. It's freely available. All the resources are free. The data sets are free, and we'll talk about that. And we'll practice on it. So you see, this is a tunnel-shaped graph. I would say a graph, okay? What is happening is, I'm sure if you can follow, all of you can follow the cursor here. This is a trend line. Okay, it's an upward moving trend line because how I can say it's an upward moving trend line because the starting of the line, you see there are dots. These are the values of my data set. These dots are very near to the trend line. But as I expand my time period, I move up on the trend line. You see the dots have scattered around. Okay. This means this particular graph literally shows me that there is some amount of non-constant variable present. Non-constant variable present as in, like in the beginning, they were all correlated with the trend line. And as and when time passed, they are moving away from the trend line. So there is no constant behavior. They are non-constant deviations because of standard deviation. Now, let's talk about a little bit on this note. I will talk about a little bit about standard deviation also. If you talk about standard deviation, it starts from the mean value. That means I'm talking about average of my columns. Okay. Each column, I'm talking about average or mean value because standard deviation is correlated with mean. So my entire data set is divided into 3 standard deviation values. If my standard deviation is from 0 to 1, in the value, if it is from 0 to 1, it is said to be 68% of my data set. If it moves on from 0 to 2, okay, then it is said to be 95% of my data set, wherein we talk about the p-value also. But if my standard deviation value is away from the mean value from 0 to 3 levels, then that is my 99% of the data. So higher the standard deviation, I assume the non-constant variability of my data set is increasing. So heteroskedasticity increases if the standard deviation value is high. So if in your data sets you are finding through descriptive statistics, I'm sure I'll show you also if you haven't done, but if you've done descriptive statistics, it will show you standard deviation value automatically. If it is very high, if it is beyond not 3, we'll take normal number as 7 or 8. If it is beyond 7 or 8, you have heteroskedasticity present in your data set. That needs to be corrected. Okay, we'll talk about how it is corrected. So it's a tunnel shape cell value. In the initial time period, it is all co-joined with the trend line. But as and when time increases, it goes to non-constant variability. Let's understand multicollinearity. Okay, the picture is perfect here because there is one dot and then there are 7, 8 dots conjoining the one dot. That means they are all similar. They are all correlated with that one pink color dot. That shouldn't be present in my independent factors. Okay. So this occurs when two or more independent variables are highly correlated. For example, if I take, let's take our colleges. Okay, all of us are from universities. So what happens is when I'm collecting a data, I'll collect some universities are from Northern India, some from Southern India, but all have one common word, that is university. So while calculating or while performing regression analysis, there is a chance that the word commonality is taken. So instead of telling me that there are 40 universities from North and 30 universities from the South, the regression analysis tells me there are 70 total universities. 70 is correct, but the interpretation is incorrect. It is not telling me how many are in the North and how many are in the South. So that means somewhere or the other, my independent factors, the cell values of my independent factors are highly correlated with each other. Okay? We have ways and means to find out how much is it correlated. We'll do that too. But yes, my independent factors are correlated with each other. This means that there is multicollinearity in my data set, which does not give me correct value or correct regression analysis. It gives me an inflated value, okay, or unreliable coefficient estimates. I don't need unreliability. Why am I using the softwares then? So I need to correct them, or I need to know how much and which particular independent variable is leading to this kind of a conflicting analysis. Okay. So multicollinearity and heteroskedasticity both are to be watched for. That's what we have learned today. Okay. I hope it is clear up till now. Shall I move on? Or do you want me to take the doubts in the end, right?
Yes, ma'am, that will be better. I think it will be a chaos. So
I,
let's.
I get your point. All right. I get your
Yeah.
point. All right. Let's move on then. Okay. Please keep noting your doubts. I'm sure you will have some. Then comes the importance of assumptions, which we will see while performing these analysis in various softwares, whether in reviews or in your, uh, yeah, whether in reviews or in JASP or even on SPSS, whether you are doing it. Importance of assumptions is always there. Okay. In regression, we assume that there is homoscedasticity. That means my independent variables are not connected to each other. Whereas the fact is they are. So both are present. Heteroskedasticity and multicollinearity both are present. I should know it. Okay? I must not follow an assumption. No, I have collected my data well. That means there is nothing wrong with my data set. No, that's not possible. We should always recheck. So that's an assumption that we should always check for these two factors or these two problems. That is multicollinearity and heteroskedasticity. Oh, my presentation. All right. So in order to detect heteroskedasticity, we employ various methods. Brosh-Peggin test is something that we will learn today, or we will see today actually, what learn. It is just a tick mark on the software itself, okay, which is also a part of VIF. We will see what is variance inflation factor, because my regression analysis is inflated. Okay, it is inflated because of presence of heteroskedasticity. That inflation rate I need to know, whether it is high or low. So this inflation rate is calculated through VIF, and which is a Brosh-Peggin test. Okay, so we'll see that today. Let's do the theory first, and then we'll come to the practical part. Uh, Addressing the heteroscedasticity can be, transforming through variables, least square methods, heteroscedasticity and multicollinearity. What to do next, we'll talk about by the end of the lecture. But at the moment, let's try and find out how to find out multicollinearity and these two issues. How are they recognized in any data set? Okay. Let me show you this anatomy of multicollinearity also. So multi means referring to multiple independent variables within the regression analysis. Now, these are independent variables. They shouldn't be correlated at all. But if they are correlated, then that's a problem. Okay. Call is a modification of prefix, okay, meaning joined together, or that means there is tandem is linear. Of course, I'm calculating linear regression, so it's called linear, linear because it is a linear equation. And suffix is just multicollinear also, you can say, or multicollinearity also. Both ways it is possible to say that. All right, let's move on. I'm sorry, I just got distracted. Yeah, okay. Now, detecting multicollinearity, one of the most important factors of performing a regression analysis, whether through econometricians or whether through statistics, everything. It all comes to detecting it. Okay? Yes, you must have collected your data sets with utmost honesty and everything is fine. But if there is a presence of heteroskedasticity and multicollinearity, we have to check that. So we can use variance inflation factor, VIF, which is automatically calculated in the software itself. Any software, you use SPSS, CPUs, or you use JAS. Okay? If the value of VIF is 1, that means it is perfect. There is no multicollinearity present. There is no heteroskedasticity. You are go ahead. Your regression analysis is super. If VIF is 1, okay? If VIF is, the value is in between 1 and 5, we can say there are some cells which are correlated to each other. Fine. But understand, if your value is above 5, then there is a problem. Definitely a problem. And if your VIF score is above 10, then something is definitely wrong or corrupted in your data set. You need to change the entire analysis. If your VIF values are more than 10, change the entire data set. Something has been already corrupted while you were collecting it or performing the regression analysis or something. VIF should never be greater than 5. That's what a very basic assumption that we take. Okay. So I'm repeating the values. I'll share the presentation also. It's for you all to keep it. VIF 1 value means perfect. You're good to go ahead. 1 and 5, doable. There are some cells, maybe I'm working on big data. So there are like 10,000 rows altogether, right? In 10,000 rows, if there are 4 or 5 variables correlating with each other, fine, doable. It's doable. 1 to 5 is okay. Above 5, still correction. You can still correct it. Above 10, you need to change the entire data set, or you need to change the entire equation analysis. You can't go ahead with the same data. You should not go ahead with the same data set. Okay. We'll see how to calculate VIF. We'll see that too. Finally, using JASP. I'm sure most of you must have downloaded it. I'll come to the practical part. This is VIF. Again, interpreting results I will show. Now, I'm going to my software here. Is the screen visible?
Yes, ma'am.
Yeah, okay. All of you must have received the link for downloading JASP. If not, it's okay. It's a 5-minute process. Please do it at your ease. It's fine. But understand, how am I doing it, okay? How am I opening a data set in JASP? How am I performing correlation and regression? I will show you today, okay? Before that, I would go to the book also. I think I had forwarded the book link as well. This is the book link. Let me know, Shivangi, if the book is visible.
Yes, ma'am, it is visible.
Great. Okay. So this is the book I'm referring to today. Even you can refer to. Why I'm referring to this book is because I'm going to use the same data sets. Okay? And it is the latest version. It is 2024 only. So at least till 1 more year, you can use the same book for your analysis and your data sets for your practice. Everything can be used. So I would request, if you all have this particular book with you, please, after the contents, go to page number 1. Okay. There you will see the preface. Preface is there. Below, just above the author's name, you will see there is a link which says datasets used in the document are available for download here. Okay. If you just click on this link, double click, please. It will take you to another Google link. I hope the Google link is visible to all.
Yes, it is.
Okay. Now, once you click on that particular link, let me know, Shivangi, if you want me to repeat any step, okay? By habit, I go quite fast, but if you want me to repeat, let me know. Just open the book, go to page number 1. After the contents, there is a line just below preface. It says that the data sets are available on this link. Click on that link. It will take you to these data sets here. The handbook data. So we have independent ANOVA data set. If you notice, all these data sets are in CSV files. CSV files are comma delimited. That means if your data set has commas, it is fine. Okay, it will rather take the CSV file. Normal XLS file will not work on any major software these days. You have to convert all Excel sheets into CSV files. If you haven't done that with your data sets, it's fine. The moment you would like to use JAS, you can convert. Okay. Here it is. I would like you all, if you have the book and if you're able to see what I'm doing here, please download the jump height correlation CSV. Okay, this is the one that I'm going to perform today. Only one at the moment. I will do correlation on this particular data set. I'm going to click here. Just click on jump height correlation. It will open another page. There you go. So this is the data set. It looks like this. Jump height as in definitely we're talking about a sportsman here or a sports person actually. We're talking about a sports person here whose jump height is given. The meters are given and the leg power. So I'm trying to correlate these two variables, X and Y is there, correlate. Okay, I'm not performing regression. At the moment, I'm only showing you correlation. So this data set, if you see my screen, these are the 3 dots right in front of the name of the data set. These are the 3 dots. Do not download file metadata, okay? File metadata will ask you to log in and all those other things. Just click on these 3 dots. You will see download. Download your CSV files through these 3 dots and download the jump height correlation. It is always preferred whenever you download a data set, you save it in a folder. Okay? So your folder should already be made and then you can save this jump height correlation CSV file on that particular folder. I already have it, so I'm not going to do that. But you can download it. Okay? Download it from here. I'm going back to the data set. So we currently downloaded jump height correlation. Also, scroll down. You will find another data set for regression. There it is, rugby kick. Download this particular data set as well, please. These 2 data sets are what we'll work on today. A rugby kick regression is there. I'm going to click on the data set and open for you. There you go. It has too many variables. Okay. This is the regression data. Okay. This says regression. So this is the regression data. Again, from the 3 dots, please download the data and keep it safe with you. Okay. These are the 2 data sets we will work upon today. So we have regression data and we have a correlation data from this particular link that is provided in the book. The book is freely available for you to use whenever you want to. I can show you some data sets from the last years also, so for last 5 years as well. But these are the newly installed data sets, so we'll work on these 2 today. I'm coming back on my software. This is what your software should look like. The face of the software, JAS, is like this. So you see only the meta-analysis part is colored. Rest everything is gray. It's fine. If your software looks like this, it is okay. Okay, do not worry about that. Can I move on, Shivangi? Am I going too fast?
No, ma'am, I think it's fine. I have, written a message in chat also. If anyone will have any kind of issue, so they will drop a message to us. So I think there are nobody's dropping a message, so I think rest is fine.
All right, great. Okay. So I'm moving on. Okay. You see these 3 dots here on the left side of your software. Just click on that. Okay. says open. When I click on open, or just put the cursor on open, it shows me recent files. These are the data sets that I've been working upon. IMT stats, these are some of the ones that were previously installed. So these are the data sets that I've been working upon. Recent files, it is automatically saving it, all right? This particular software will automatically save. You have to click on save, yes, but okay. Then there are data sets on my laptop, okay? So on the computer itself. So there's data from JASP. I've already made a folder for that. SEM files are there, regression files are there, factor JASP data is there. So whatever it is, yeah. OSF and database is not required because it will ask you to register. Not required at all. When freely it is available, then please do not register. Coming to data library. This is something very interesting for you to work on or for you to practice, okay? If you click on data library, there are let's say I'll click on descriptives. So there is a sleep data set here. You can download it for free. Okay. Then going back to the categories, there is t-test, regression data are also there. Adam Sandler is there, sales data is there, auction data, world happiness. These are also some of the data sets that you can work upon. Titanic is something I've worked upon previously also. So it's a very interesting data set. We can download it later as well. It's fine. Okay, I'm just showing you around. So not going to data library, of course. I will go to computer. But before that, let's come back here. Okay. Some of you might not have some of these. After frequencies, you might not have any other variable, right? Or any other ribbon parameter. So you see a plus sign here on the right. Click on the plus sign. Now you can add it. I have added predictive analytics here. I have added meta-analysis. I have added factor analysis. You can add whatever you wish to work upon. Okay. Distributions, meta-analysis, PAR, machine learning is there. Machine learning, some parts are paid, so let's not do that. Predictive analytics, I have already clicked upon. Reliability tests, SEM, it's a very high analysis these days, but if you're doing regression analysis, it's fine, I guess. It's equivalent. Summary statistics I've added and time series I've added. You can add whatever you wish to add. Okay. Visual modeling is also there, which is very smart aspect of this software. But let's come back to our original point. Okay. So you can add various other aspects also if you wish to from this particular plus sign. Okay. Now I'm going to add my data and start working on it. Finally. So I'm going to go back to the three dots on the left, open. I'll go to my computer. All right. The data set is here. My folder is already ready, data JASP. I double click on that. When you double click on that, you will see these all are CSV files. Okay.
Ma'am,
Yeah.
So sorry
Yeah.
to interrupt. One of the participants requested to slow down a little bit of installation process because they are working together. So they just requested if we can a little bit slow down.
My apologies. Yes, please. Okay. I'll wait a minute. No worries. I'm so sorry. Okay. Uh, you know, when you're doing it on daily basis, it tends to increase your speed. So
One
that's
of
where
the
the practice matters.
participants also requested that how to install it. Like there are 2-3 questions back to back.
Do you, okay. Okay. Do you have the book? Do they have the book? Is the
Request
book with them?
to reply on chat.
Yes,
Whoever.
we
Okay,
have,
I'll
but
repeat. Okay, you have the book. I'm going to the book. Okay, let's go back to the book. I'll tell you everything. All right, let me just, yes, good. You have the book. This is the book. Okay, this is the particular book that I have asked you all to open. This is the book that you all have. Just scroll down. After the contents, okay, you will see a preface. It has 2 links. This preface has 2 links. One of the links is to download Jasmeet. So click on that link. You will scroll down. Let me just show it to you. Yeah, it is. Okay, allow. All right. This is the link that will help you to download. Okay, it is already showing me download Jasp here. It's a free version. 19 is a free version. 19.1 is also there. Okay. Download Jasp. But if you scroll down on this website, you will see various other aspects also to download. Okay, it is not showing you here, but to download it on your MacBooks, let's click here. Okay, download JAS. There. The moment I click here, now it is showing me various options. I can download for Windows, Mac, and Linux, all the three. Download Intel version. If you are using MacBook, download the Intel version. If you are using Windows, you can download the Windows installer, not the zip. Okay. Download the Windows installer. For Linux, Flatpak. All the three are there. So you can download from here. Okay. Is there any more query about how to download it? I'm going slow. Okay. So your book, the preface page, I will repeat everything. Don't worry. Priyanka, yes. Okay. Now I think you know how to install it. It is asking you to repair. Please repair and refresh your laptops. It's fine. Wanting you to restart your PC? Yes, because it is repairing some of your Excel books that you might have previously downloaded. So it is just asking you to do that. It's fine. Don't worry about it. Just click on repair and refresh your laptops. It will start working. It's a very simple software. Oh, you want me to share the data here? Okay, I can do that. Somebody can do that. Can you do it, Shivangi?
Ma'am, could you repeat?
Somebody is asking me to post the data here. Shruti, I guess. Yeah.
Let me just cross check with Fidosa once.
Okay. Or else I'll show you how to redo that. It's fine. Okay. No worries. All right. So now that we are all here, we all know how to download JAS. It will take 5 minutes maybe to download it, and it might ask you to repair. Please repair and restart your laptops or computers, whatever you're using. It will work on that too. So this is, I'm coming back to the book again. So the book had, the preface had 2 links. Okay. This is the first page itself. After the contents, it is the first page. It has 2 links there. The first link is how to download it. All right. And the second link is down below. It says the statement here, data sets used there. I'm just making it blue. This link is where I'm downloading the data sets from. Click on this link, double click on this link. It will take you to, I'm using Chrome, I'm using Firefox actually. If you're using Chrome, it will directly open the Chrome fact for you. These are the 2 links. If the book is all there, the book is freely available for you. One link is to install, and the other link is to download the data sets. If you click on this link, it will open this page for you. It looks like this. That link, if you open, it is saying JASP handbook data. Just click on that link. It will show you the data sets. Okay. That's okay. Jump height correlation is already there. Rugby kick is already there. Thank you, Vibhuti. Okay. I am doing it again so that you all can follow the steps as well. It's not difficult, but the only thing is if you're writing it down, it's fine. So these are the data sets. We are we have it in the book. Okay. We will work upon 2 data sets today. It is already there in your message box, but I will redo that. Jump height correlation and rugby kick. Jump height is for correlation and rugby data set is for regression analysis. Okay. When you will click on jump height correlation, let's do one by one. Click on jump height correlation. It will open another page, which is this sort. There it is. Jump height correlation CSV. It's a CSV file. Do not download from the right side of the page. File metadata and all that is not required. If you click on these 3 dots right in front of the name, click on these 3 dots. It will show you download. Just download this. Okay. So you've downloaded jump height correlation. Another data set that we'll work upon today is your rugby kick regression. Download it in the same manner. Click on that. It will open this page. Download through the three dots and make a folder. Make a folder of these two data sets. Okay. Can I go back to the software now, or should I wait? Let me know.
Let's continue, ma'am.
All right. So coming back to my software, okay. All those who've just downloaded it, your JAS main screen should look like this. It is an open source project, and there are various universities part of the same. PJ is also part of it. I believe Texas A&M is also part of it, and all those Tilburg University, the names are down below. You can see all those, yeah, Texas A&M is there. So all those universities that support JAS is mentioned. Okay, this is how it should look like. If your front screen is showing these gray, it is fine. Okay. Don't worry. The moment we'll upload the data set, it'll all come with colors. Okay. No worries. At the moment, if they are gray, let it be. If you want to add on few more parameters, just click on this plus sign on the right. And you can add whatever you wish to. Okay. Audit, circular stats, meta-analysis, distributions, t-test, JAGs, I don't think so, you know, machine learning, predictive meta-analysis, SEM, summary stats, time series analysis, visual models if you want. You can add on all these. I've added a few. I've just added meta-analysis and all that, predictive and SEM. You can also add if you want to. Shall I paste the data? I'll show again, don't worry. Clicking on the three dots on the left, bring your cursor to open, bring it to the computer because your laptops must have saved the data sets that we just downloaded. Click on the, double click on the folder that you have saved your data sets in. Okay, just double click on the folder. Since I have few more data sets, it's fine, but you should have jump height correlation and rugby kick in the folder. Both the data sets should be visible to you, but I'll click on jump height correlation currently, and I will simply click open. Okay, just click on the jump height correlation and click open. It has imported the files. This is how my data set looks like on JASP. Okay, there are a few more people waiting. Shivangi, if you can just check it. Or can I cross it?
Done, ma'am. I have added all.
You've added also, I can cross it. Now, so the moment I added my data set, you see all of this is orange and red and brown and everything. The colors are added. Okay. That means it's downloaded properly. It's all set and done. So you see the jump height data set and the leg bar. All right. This is X and Y. It's fine. Now I'm hoping that you all are all aware that the first column is usually my dependent variable. Whatever Excel sheets you're working upon or CSV files you're working upon, the first column, apart from the days and date, okay? Apart from the days and date is usually my dependent factor. So herein I'm assuming, again, assumptions, okay? I'm assuming that jump height is my dependent factor and leg bar is my independent factor. That's okay, but that's Okay. Now, if I double click on the name of the column, jump height, double click there, it opens this sort of a description here. Okay. The scale. Can anybody tell me what is a scale?
Measuring the data.
Great. Thank you. Measuring the data. Usually the scale is a numeric value. Okay. Usually what? Most of the times scale is a numeric value. So whenever we wish to perform on JAS, make sure that you are performing on scale data. Okay. Whereas there would be some data sets wherein you have ordinal data and nominal data. You see, ordinal is showing you a graph sign, and nominal is showing you the three circles coinciding with each other. Anyone, any idea what is an ordinal data?
Ordinally is ranking.
Ranking, ordered with an O,
Quantitative
right?
data. Qualitative
Except
data
for-
may be no, ordinal and nominal.
Right. Ordinal is quant or ordered. It can be ranked or ordered. I don't need ranking at the moment. So I'm not taking ordinal data set. Nominal data is an alphanumeric value could be present or something of that sort is there. It is a mixed data set. Okay. None of those work on JASP. The only thing is you have to change your data scale to scale. Okay. Always remember, whenever you're performing anything, any analysis, make sure that your scale is as per scale and not ordinal or nominal. It can be easily changed. Numbers having mean associated with this. Yes, thank you. Ranking, ordinal, interval, ratio. Yeah, exactly. It has ratio, it has interval scales, groups, it has everything in it. Great. Coming back. Now, so all this I can see it's already the scale value. Okay. I'll just cross it from here. These are already scale values. So I don't have to change anything. Now, simply go to regression, click regression, classical. We are not doing Bayesian. Click to classical correlation. Now, it opens this sort of a page. Okay. On the left side is your worksheet. On the left side of your page is your worksheet. The right side is your output. At the moment, let's concentrate on the left side. Okay. The worksheet. It is asking me the variable. Since it's correlation, there would be two variables. Clicking on jump height, click on this arrow. Jump height is on this side. Leg bar, click on this arrow and it is here. So I have two variables. I'm only looking at the output, at the worksheet right now, okay? The workbook. I'm not looking at the output. I'm only concentrating on the workbook. What kind of an analysis I'm giving the software to perform, okay? So I've given the two variables X and Y. Scrolling down, you see it is showing me Pearson's correlation. Small r is a correlation, right? Pearson's fine. Spearman's rank correlation can also be done, but my data set is not ranking. If I would like to compare two countries or two athletes together, then ranks might be required. But at the moment, no. Kendall's-Taubes is absolutely different. That is for data, big data. Okay? So Pearson's is automatically by default clicked. How many times will I make this person enter? Shivangi, please take care of that. Okay?
I am
So
adding.
Pearson's, okay, thank you. So Pearson's correlation is something that we want to do. Okay. Display pairwise are not required. Report significance, yes, we need report sample size and covariance not required. If need be, you all can click on that. Hypothesis is correlated. Yes, of course, I think they are correlated. Then I'm clicking on scatter plots. Somehow I am very fond of visualization, so I'm clicking on scatter plots as well. I will show you heat maps, okay? Not required for correlation, but I will show you why it is needed, okay? Then come to assumption checks. Assumption checks, as I mentioned you in the presentation also, it is there and then these options are there. not required at the moment. So this is how my workbook looks like. The entire modeling structure is completed. I can remove this analysis, show info, duplicate, edit, of course, and I can transfer the entire thing on software known as R. If you're well versed with coding, then do it or else don't. Now I'm coming to analysis part. Okay. So input is done, my workbook is done. I am coming to the output now. I did regression, classical correlation. I am redoing it. I have no idea why it did not show. Both of them taken together. Correlated, yes, I will do the, not showing here, right? Am I audible enough, Shivangi?
Yes, ma'am.
Yes, right? Then why isn't it working? Scatter plots should be shown, heat maps. Okay, sorry. Heat. Oh, I'm sorry. Heat maps are shown, and there you go. Why isn't the visible? That's weird. Let me just refresh my entire software, maybe. No, I don't want to save. I will now close it. Let's see what is happening at the background. Going back to my software again. Yeah, it is taking time to open. That means it needed refresh. Okay. Yeah, it gets bigger, of course, but it wasn't showing at all. Anyway, I'm just redoing the entire thing. So height correlation open. It has downloaded it, performing the regression and correlation there. There you go, waiting. Now it is visible. Variables are here. Bar is here. Visible. It needed a refresh. I think so. Scatter plots. So, and then the heat. Okay. There you go. Now, you see the correlation value? Jump height to leg bar is 0.98. What does this mean? 0.98?
Highly correlated.
Highly correlated.
Thank you. Thank you, Augustine. Yes, highly correlated, high positive correlation. It could be negative also. Correlation can be negative. Remember that, all right? Very high positive correlation. I can show you through the plots as well. Okay. You see very high positive correlation. You see the trend line. All the major cell values are either on the trend line or near, absolute near the trend line. Okay. And since it is correlation of one factor only, so assumingly there is no multicollinearity or heteroskedasticity. Okay. Heat map. Let me show you the heat map. Sometimes it shows like this because as somebody clearly mentioned that you need to drag. And there's less of space, so that's how it happens sometimes. The moment I'm dragging it, it will show me. Oh my, what have I done? The heat map, and that's where it is not going. Finally, the heat map is there. There it is. Okay. 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 There you go. The heat map. The heat map will basically show you both the correlation factors. Okay. Jump height to leg bar and leg bar to jump height. Both of them are 0.98. That means they are high positive correlated. Okay. This is how it looks like. But this way, looking at this, since it's only one analysis, right? A linear analysis, I can simply assume, again, assumptions, I can simply assume that there is no multicollinearity or there is no heteroskedasticity because I haven't performed regression yet. The problem comes when I will start performing regression. So I'm crossing this data and I'm going to perform regression now. Okay, I will resave and reopen my entire software so that it's easier. High positive correlation. Yes, thank you. So this is how it looks like. Fine. I'm going to open again the folder. This time I will choose my regression data set. Okay, rugby regression data set and click on open. Now this data set, if you see here, it has everything combined. It has only ordinal and scale data. Okay. I can use this because it is already pre-uploaded in the software. Okay, so I will use this. So let's say I'm using only scale data, remember? So distance, R flexibility, but I will somewhere or the other, I will use R strength also. Okay, so this is the data set available for regression. So that means distance covered depends upon your right strength, right flexibility, left strength, left flexibility, and bilateral strength. Okay, again, a sports person's data set here. But of course, I can see, since this is my first column, so I can see distance is my dependent variable. Okay, so I'm going to regression. Again, classical linear regression. Clicking on that, it opens again the two workbooks. Distance is my dependent variable, and it's a scale value, perfectly entered. Now, I will enter R flexibility as covariate, independent. I need one more independent, okay? So I will take R strength, or let's take L strength, either of them. L strength as my second. So it has shown me a star. It has already converted an ordinal data into the scale data. So I don't have to do anything there. It has already been converted and it is showing me a black star as well. Fine. So I am assuming in my regression equation that distance is depending upon R flexibility and L strength. I assume that R flexibility and L strength are two independent factors or covariates. They are not correlated to each other. I am assuming that. All right. So let's see the workbook first. Model needs no explanation. That is just the software model structure that it has taken. Model 0 is your hypothesis. Okay. So model 1 is the one that we are playing around with, of course. Come to statistics. Click on statistics. Okay. This is where I will know whether or not multicollinearity and heteroskedasticity is there or not. Okay. So I don't need all these, Durbin Watson. I need tolerance and VIF. VIF is your variance. Variance inflated factor. This I need to add. So I have clicked upon it. Okay. And I also need to check if there is VIF, present. So which independent factor should I play upon, or which independent factor is creating the problems, right? So I will click on collinearity diagnostics. These are the two factors. One is checking heteroskedasticity. Second is checking multicollinearity. Okay. This is in statistics. Method specification and plots are already done. We don't need that. This is my workbook. I am coming back to my analysis. So you see now, let's start with linear regression here. Model summary, M0 is 0, all 0, it's fine. M1 model, that's where we need to look at. Correlation is 0.81. It has all automatically calculated. We should have done it before, but we'll redo that. Correlation is 0.81. R square is 67%, 0.67. That means if I write down my statement, it says that distance is 67% regressed or dependent upon those two. What were those two? My L strength and R flexibility or something of that. So those two independent variables. It is 60%, 67% dependent. It's still moderate regression, right? 0.67 is moderate regression. Fine. So they are actually regressed with it. Moving on. This is your ANOVA analysis. Some of difference is there. Residual values are also calculated. That's okay. I'm sure F value is there. P value. It is less than 0.005. Perfect. Abhi tak it's like, okay, fine. I don't have any heteroskedasticity or multicollinearity. Okay. Let's look into the coefficients. There. In the coefficient section, okay, this is where you will see standard errors is intercept value ka standard error is 216. Let it be. R flexibility standard error is 3.4, doable. L strength is perfect, 2.5, somewhere in between my data sets. Good. Look into the VIF. The inflation factor is 3. 1 should have been perfect. Anything in between 1 to 5, 1, 2, 3, 4, or 5, that means there is moderate multicollinearity present. Moderate is present. My entire regression is moderate, right? So moderate multicollinearity VIF is showing me. That means somewhere or the other, my independent factors are correlated with each other, moderately correlated with each other. So VIF is clear, but I want to know which independent factor is the problem. Where? Why is it 3? What is happening, right? So now I come to diagnostics. This is how you interpret your output here, okay? Coming to diagnostics, okay, till intercept value, it is okay. I'm not concerned. This is my M1 diagnostic, my model. R flexibility and L spread. Okay, it is showing me variance proportions. Basically, it is showing me the correlation factors, correlation values here. So you see, L strength is 0.001, fine. 0.36 nominal, 0.63 moderate, okay. R flexibility, first dimension is 0, second says 0.001. The third dimension of standard error shows 0.99. That means somewhere or the other, the third dimension of our flexibility is a problem. That is where some amount of correlation is present. So what I will do now, in order to correct it, either I can simply ignore. Either I can simply ignore based on the fact that, okay, fine. It is there. I corrected my data set automatically and all that is done because I can say that my p-values are fine. So why do I need to, how can you say my data is corrupted? I can ignore one thing. Second, I can use logarithm values, which is the most common practice to correct heteroskedasticity and multicollinearity. Go back to your data sets, your Excel sheets, just click on log values for that particular column. Now I know which column, right? Because my R flexibility is an independent variable. This is the problem. So for this particular column, I will calculate logarithmic values. Okay. The third possibility is I know where and which cell I might have actually averaged, or there might be a missing value that I treated, or there might be just a random number that has been misspelled, or there is a human error, which I'm aware of. So these are the 3 aspects that you can correct it. The first one is the very simpler one, easy one, that you simply ignore it. But you should not, because then it will give you wrong analysis of your regression. Now that it is showing you actually that R flexibility is your independent factor, which is creating problems, which has high correlation value. 0.99 is equivalent to 1 only, right? Which has very high correlation value with L strength. So something is not right there. And there is a possibility I might have done a human error, which I am aware of. So these are the ways and means we correct it. The most basic format of correcting this is through logarithmic values. There are certain data sets or certain statisticians that will also tell you to calculate these square values. If you don't want to calculate logs, you can calculate square values of that particular column. Then also your multicollinearity and heteroskedasticity is checked. Okay. Here in my VIF value is in between 1 to 5, that is 3. So it is showing me some moderate correlation is there. Now I want to know where, right? Where is that moderate correlation in between which two independent factors? So it is actually very evident with R flexibility. This is the independent factor wherein the multicollinearity exists. And this is where I need to correct it. Okay. These are the two models that I wanted to show. In correlation, you cannot check multicollinearity or heteroskedasticity because there is only X and Y. There is only possibility of these problems arising in regression analysis. So whenever, in whichever model structure or any of your research papers, if you're presenting regression analysis, please show the coefficients of VIF and also show the collinearity diagnostics to tell the person or to tell any of the editors of any journal that you have already checked with your data set. It is fine. It is moderate. It is okay. But for instance, if this VIF was above 5 or above 10, then that means my entire data set is correct. Then something is definitely wrong. If you present this to any of the journals or any of the international conferences, they will straight away reject your paper because you have worked upon VIF, which is very high. And if you will not give them, they ask for the raw data sets also. That's the basic reason that we will need to check the multicollinearity, the heteroskedasticity, is that present or not? It is only through VIF that we can check it. And that's how it is done. I am coming back to my presentation. I hope I've covered all the points. I have shown you the practical VIF methods. Interpreting results also we are done. And conclusions and recommendations. And this is my email ID. I'm going back to my output in the. There you. I'm open for practice session if you all want. We can download another data set and perform regression analysis and check it for ourselves. Are you all open for the same? Shall we?
Now, first, we will like to resolve our doubts.
Oh, yes, please. Go on. Sure.
Ma'am, what are the dimensions? We have taken two independent variables, but
Yes.
there we can see 3 dimensions. And what are those dimensions and what is the relationship? 1 to 2 to 2 to 3 or something, which I didn't get it, ma'am.
These-
Please.
Okay. Yeah, sure. See, yeah. Dimensions are basically talking about standard deviation dimensions. You remember in the beginning of the class, I mentioned about 68%, 95%, or 99%,
Yes. Standard
depending
deviation
on the
1 and 2,
standard.
3, yeah, away from the
Yes.
mean. Yes.
Exactly. That is where the dimensions are playing a role. Dimensions are not important here because I already know, if you look at the variance proportions, I already know this correlation values, right? These
Yes.
6 values, the highest is 0.99. So that means my R flexibility in that particular column, if I go back, I'll show you the data set, the data. In this particular data set, R flexibility, something is either misspelled, wrongly entered, or there is a problem in this. If you see the data set, let's look into the data set also. It doesn't look like that there's much of the variance here, but there is some problem in this particular column. So I can perform log here and recorrect it and then come back to my model, redo the thing, then the VIF will reduce. That's the major importance of collinearity diagnostics. Is this
Can we do
Jasmeet,
that, ma'am, now?
can we do that as it is a perfect correlation? It's a 1, right, ma'am? So can we do as an example of converting into the logs? Is there any option in the JASP?
Converting into, no. You will have to convert it in the Excel sheet,
Okay. Okay.
not
Excuse
on
me.
the software. Yes, sir.
There are few guidelines for all the participants. If you are having question, you should not cross yourself and jump, quickly to the resource person. We have moderator for this. So you can raise either hand and then moderator will issue,
Okay, sure, sir. Taken. Point
So
taken.
by jumping again and again, so it will, interrupt the session. So
No,
you are
sure, sir.
requested to raise your, hand, write down the question. Then moderator is there. So kindly go ahead.
Okay, everybody had that question of dimension. Thank you, Prof. Okay, point taken. So dimensions are explained. Anybody, any other issue, please raise your hands so that Shivangi can actually.
Any further questions anyone wants to ask?
Okay. So let's, if there are no questions, I think let's do
One of the question is there in the chat box by Aditi. She's saying that kindly repeat the process of regression. So if
Yes,
it's
okay.
shorter one, so we can just give a little bit.
Absolutely. Yep. I'm just crossing my entire software again so that it is refreshed again and again. So let's do one more thing. Okay, let's save it. You all can save actually, that's fine. So this is my software again. Let's go to the data sets again. Okay, I'm going to the data library this time. Okay, in the data library, I would wish to download from regression maybe. Let's download another data set for your practice and then do it. Let's download, where did that go? Titanic. The age, cabin class, survival status of 13 passengers on the Titanic is given. All right. Open the data file. Just double click here. It will automatically open the data file. Okay. Now you see the names are given, which is, of course, alpha values, not numeric. Passenger class is given, which is alpha and numeric first, second, because it's given as per the Roman numbers. Age is there. Their sex has been mentioned as male, female, all right. And survived status is also there. Okay. Since it's a regression, okay. Since it's a regression analysis, I'll just look into the entire data set again. There are 13 sets. Okay. Now, age has missing values. This should be, okay, let's not get into the details. Let's go to regression, go to linear regression again. There you go. So age. Age should be my dependent because that is my first scale value. And let's see how many of, as per the age value, how many survived. Okay. See, it has already converted the, now, since I'm calculating regression and I want to check VIF also. Okay. So I'm just adding one more covariant. You can enter or you cannot enter, but all these are alphanumeric. So I'll enter the passenger class. No, passenger class is not taken as it is not able to convert it into scale. Sex, I don't think so will be converted because it's absolutely yes. Again, it will not convert. So this particular regression will happen in linear form. Name will definitely not convert because it is all, yeah, it's not able to convert. Yeah, okay, fine. So I'll stick to one only. Let's do this only. Okay, age is dependent on survival. Okay, the survived number of people. Let's do that. This is a regression data. I'll just scroll down. Model structure, of course, it will give you two models, M0 and M1, depending on your hypothesis levels as well. So M1 model is survived, okay, which includes the intercept. Coming to statistics, this is the major part because I need to click on tolerance VIF. I need to understand what is the VIF value. And then let's do the collinearity diagnostics also. These two are the tick marks that you need to remember. The VIF is your variance inflation factor, okay? Because what happens is whenever there is multicollinearity and heteroskedasticity present, it inflates your regression analysis. That is why VIF is calculated. And multicollinearity, I need to check what independent factor is there that is creating issues. At the moment, it is one only. So let's see what it gives us as result. Going to the result. It's, of course, as anticipated, the correlation is not much. Regression value is hardly 4%, which is not much. So yeah, age had nothing to do with the survival ratio, okay? In Titanic, it had nothing, no role to play at all. But still, let's look into the output. We are here to practice, okay? Now you see, VIF is 1 in the coefficient. VIF is 1, which is perfect, but my p-value is 0.09. So somewhere or the other, the data is corrupted, but p-values and f-value, if you see 2.8, it's fine. So there are a lot of confusions. So that's the reason most of the times people ignore multicollinearity, which shouldn't be done, but people do that. Okay. But if you look at, but if you look into below the collinearity diagnostics, okay. Again, the dimensions are divided into 50-50 here. Intercept values are not to be seen. Survive correlation 0.17 and 0.82. So again, dimension 2, that means the data, 95% of the data, dimension 2 is after 68, comes 95, then comes 99. Okay? So 95% of the data is kind of the survived value could be, could be human error or could be just corrupted. So we can say that. But VIF is positive. It's 1. It's perfect number. We can go ahead with this kind of a data set. This model structure will be accepted by any journal or any conference because your VIF is 1. Despite of the fact that it is showing me survival rate ratio is 0.88, dimension 2. There could be some miscalculation or some human error. That's fine. But my VIF is 1. Perfect. I can go ahead with this data. So in future, if I want to forecast it something, this data set is perfect for the future. Sorry. This is how we actually study the output in JASP. And that's where we try and find out what is there presence of heteroskedasticity or is there a presence of multicollinearity or not. At the moment, since I took only one factor, so it's not clearly visible. Clear, all of you? Are there any more doubts? I can also...
Yes, ma'am. Ms. Vibhuti Mishra wants to ask a question. Ma'am, if you are there,
Sure.
please.
Yeah, hello, good evening, ma'am.
Yes, tell me, Vibhuti.
Ma'am, first thing first, I'll be just VIF factor is for multicollinearity, right? So yeah, basically just go by this this interpretation. So
Yes.
VIF is for multicollinearity. In this, it's perfect, it's doable, and it's why are we
1.
going to the collinearity diagnosis? Because if I have VIF factor, multicollinearity is good to go, and it's an
Exactly.
assumption
Yeah.
and it's fixed, then I can move forward. Now
Yes,
coming to
absolutely.
the diagnostic part, the second dimension, third dimension, it obviously gets a little, 95%
Confusing. Yeah.
confused. So is it necessary to diagnose it even if I get a VIF factor 1? First
No.
question is, okay. Okay.
No,
So
it is. Let me answer question by
one
question.
more thing,
No, it is not necessary. I am only showing you for practice purpose.
okay.
Okay, this is only for the practice purpose, but it is not compulsory at all. If your VIF is on the higher side, then you can always go back to your model, to your output. This is your output page. You can always go back to your model page and click on multicollinearity diagnostics and redo that. It's possible.
Sure.
You don't have to always do it. I am just showing it to you. That's the reason I'm clicking on it again and again.
Yeah. Ma'am, also I missed on the heteroskedasticity part. I'm so sorry for that. That higher the standard deviation, higher the heteroskedasticity, right? So
Yes, absolutely.
in this particular can you just drag it a little? आपकी screen के
Sure.
ऊपर.
हाँ जी, बिल्कुल.
So
Sure.
either we will see the R square.
R square is your regression.
regression,
R
right?
is your correlation. Yeah.
Correlation, and R square is a regression.
Yeah.
So the higher part, I need to brush up my basics before coming to this class. I understand, but right now, how did you decide that it is higher or not?
Okay. See, I assumed that all those who are attending the session today are already well versed with regression. So regression value, if it is less than 0.6, 0.6, okay, or less than 60% or 0.6, it is considered as an okay kind of regression. It is not high regression. Something in between 0.6 to 0.8 is high regressed. Okay, above 0.8, it's similar to correlation actually. Above 0.8 is perfect regression. 80% dependent or 90% dependent or 0.99 dependent or 0.93 dependent. Anything in between 8 to 9, 0.8 and above is perfect regression. But herein, if you see, it is 0.004. It is hardly 4%.
Yeah.
So
So the
it's
lower the
nothing.
better, right?
The higher the better. Regression
Higher.
analysis, the higher the better. Yes. Regression.
Okay.
Yep. Don't get confused with standard deviation. No. Standard deviation, if it is high, then heteroskedasticity will definitely be high. But this is your regression analysis. If your regression is high, then it is good. This is very low. That means it is only 4%. My age is only 4% dependent on my survival rate. 4%
Does these
is
results
nothing.
tell us about standard deviation also?
No.
So, how would
Standard
you?
error.
Yeah. So the multicollinearity part is ticked off by VIF, and how heteroskedasticity part?
Heteroskedasticity is also through VIF. If VIF is high, heteroskedasticity is definitely. See, understand. Heteroskedasticity is the concept.
Okay.
Multicollinearity is the problem in the concept.
Okay.
Okay. But in order to calculate hetero, you can always go back to descriptive statistics.
Okay.
If I click it here and I just click age ka descriptive and what was that? Survived ka descriptive. There. It has given me valid, missing, mean, standard deviation. See, standard deviation for survived is very less, which is fine. But for age, it is very high. See, now we've already found a problem here. Through our descriptive statistics. Yes.
Okay, ma'am.
Got it? Yeah.
Okay. Thank you so much, ma'am. Thank you, sir.
No worries. So somewhere or the other, that either of the two, but ages are dependent. So we can actually shift it. When we redo the regression analysis, we can shift it. We can put survived as our dependent and age as our independent factor. So, and then we can see the regression. If you all can do it, let's see what results you get.
We
Out
have
of these
4 questions, ma'am.
Oh, okay. We have more questions. Let's go ahead.
We have
Yes.
4 to 5 more questions. So one
Okay.
question is asked by Aditi. What is eigenvalue and what does it mean?
What value? Where did you see that?
It's in the chat box, ma'am. What is eigenvalue? EIGEN, eigenvalue, and what does it mean? She wanted to ask.
No, that is fine. But where did she see eigenvalue? Then I'll be.
Miss Aditi, if you are here, you can ask your question.
Yes, ma'am. It is showing in after the interpretation data. Please back your slide. Ma'am, am I audible?
Yeah, you are audible. I'm just trying to find out my data here.
Ma'am, before the descriptive statistic, the result which already shown before the descriptive statistic, where we
Before the
find
district.
yes, ma'am, the above line in collinearity diagnosis, third column.
Oh, the
Yes, ma'am.
eigenvalue. Okay. See, this is another form of a T test or an F test or something of that sort. So if you're already performing T and P values are already given, then you don't need eigenvalues. It's just another form of a test. Condition index is also a form of correlation index. So these two can be ignored in the diagnostics. That's the reason I said to you, till intercept, you can actually ignore this. The major variance proportions that you need to check is these two variables. But since we took only one single independent variable, so this, I think I'll redo the regression here so that it is even more clearer. Is that clear? These are just two more tests that can be performed. But
Okay, ma'am.
these two tests, these two tests can be ignored because you're already performing a correlation analysis. You're already doing t-test, f-test. So not required. Just concentrate on variance proportions. That's why I asked, where did you see eigenvalues? Yeah.
Okay, so we
All right.
have next question, ma'am.
Yeah.
Somebody's asking, can we use the downloaded JASP for our analysis?
Downloaded JASP as in?
Jesse, if you're here, please ask your question.
You mean the data set? Or
Good
what?
yes, good evening, madam. Thank you for the wonderful session. Madam, my doubt is already I have downloaded and it is friendly to use. So for my data analysis, can I use the same downloaded this software? That's what I asked.
Absolutely. Yeah,
Yes,
absolutely.
yeah.
That's the reason we are teaching you all these softwares.
Yeah.
Yes, you can.
Thank you, madam.
In fact, you must use all these softwares. EViews and JASP are two major ones that are, considered at a very high value in research today.
Okay. Okay. So
You should,
I
yes.
think without eViews, I can depend this on only this software. Is it possible to proceed
You
for
you
data
can take
analysis?
anyone. Yes. Yeah. You can take
Okay.
anyone. You can show both of them, but you can take
Ah,
anyone. That is absolutely
okay,
fine.
madam. Yeah, thank you, madam.
Dr. Raja wanted to ask a question. Dr. Raja, please, if you're there, please ask your question.
I have a doubt. If we are, if I'm my data set standard deviation is less than 1/3, we don't bother about
Okay.
that.
Right, you don't. Yes.
Right. If I'm not.
Yeah.
If I'm not.
Yeah. No, you're right.
It's
Yeah,
less
actually,
than
you're right. Yeah.
if I'm controlling that variations, when my data set is 1/3 of standard deviation of my data set is 1/3 of mean, I don't bother about. I don't want to bother about the VA, right? If I'm not
Exactly.
wrong.
You can ignore. Yes, you can
Yeah.
ignore.
Thank you.
Yes.
Thank
Yeah.
you. Thank you.
But there are possibilities, if your paper gets stuck in an international journal or through a conference, there might be a review that asks, that if you can send them the raw data. If while performing the raw data analysis, if they find out that your VIF is high, the chances of rejection are very high. So it is always better to recheck.
Okay, ma'am. Thank you. Thank
Yeah.
you. So
Great.
are they
No,
asked data sets? Are they asked data
yes,
sets? Oh,
they do. Yes. Yes, they do.
thank you.
And this is
Thank
the
you.
sole reason because, how else will I know that your analysis is true to itself or not? We do ask. Yes.
This is new to me, ma'am. I never
Oh,
cross this kind of.
in fact, it happened with me some years back. In one of the international conferences, I was the presenter, and two reviewers, they actually asked me if you can open the Excel sheet and show to us, So you always have to recheck. You have to be very
It was new to me, and it is very good.
No problem, sir.
In fact, it is very good because many of them are using the, very well.
I mean, we just simply try and ignore. Yeah, but we
Yeah,
shouldn't.
thank
Yes,
you,
very true. Thank you, sir.
Next, we have Mr. Augustine. If you're there, please ask your question.
Yes, ma'am. Good evening, ma'am. This adjusted R square. So as we have mentioned, it's a less than 0.6. Is it okay? Say example, ma'am, if it is a adjusted R square is a 0.2 or 0.3. Is it acceptable by the journal?
Adjusted R square is basically, it says that how well is your model fitting in?
Yes.
Okay, which obviously depends on the regression analysis.
Yes,
So
ma'am.
adjusted R square, if you see, it is literally half of what R square value is. It is 2%. If your regression is already high, if it is already above 0.6, 0.7, or 0.8, I don't think so they ask for adjusted R square things. No, that's not correlated then. Yeah. But if your regression is already low, then they might actually ask you to correlate with adjusted R square. But I have never seen or heard anything correlated with adjusted R square. No. This is just to see whether my model fits well or not, actually. That can be ignored here.
Okay, thank you.
Okay, great. Thank you.
Next, we have Miss Rimpi Kaur. Ma'am, if you're there, please ask your question.
Good evening, ma'am.
Hi.
Ma'am, my question is that if we have the independent variables like agriculture value added as a percentage of GDP and the industrial value added as a percentage of GDP, they automatically show high correlation. So, because if one go up, other will go down as GDP percentage is the sum of these two: service, industry, and agriculture. So, if there is a high BF, should we ignore it or consider it? As these are
See,
correlated, highly correlated.
okay, one question here. Are these positively correlated?
Yeah, ma'am. Negatively correlated. These are negatively correlated.
Exactly. If they are negatively correlated, I don't think so VIF would be high.
But this, the results are showing that these are high, very high.
VIF is high. How much is it?
Yeah,
How much is
it's
it? Is it above
about
10?
yeah, it's above 10.
Your data set is corrupted. Okay. So can you tell me what are the diagnostics? What exactly is problem there? Is it the third dimension or the second dimension? How much of your data set is corrupted?
It's the sixth dimension.
Sixth dimension. Sixth
Yeah.
dimension, that means almost 98 or 99, because anything beyond 99, anything beyond third dimension is almost the entire column. So your entire column is corrupted. Okay. Okay. One, yes, what all statisticians do, you can also do that. You can ignore it. If it is not caught, it is not caught. Secondly, try and find in the Excel sheet only, if you choose that particular column and convert that particular values into logarithmic values, logarithms. It is very simple
I
in
have
Excel.
already converted into logarithms.
Despite of that, it is still high.
Yeah.
Okay, then you have a corrupted data set. You can mention it in your scope. Okay, you can mention it that while performing methodology, you came across very high BFF. So assumingly it's a secondary data set, right? Not primary. So
Yes, ma'am,
assumingly
it's
you can,
secondary.
yeah, you should actually mention a point that assumingly that this particular data is corrupted already, since it's a secondary source of data. You can mention that.
Okay.
So yeah, the
Thank you.
rejection, yeah, the reviewers and everybody will see that statement and they will actually get an idea that you're not bluffing, right? You did VIF and it is high, but you cannot help it because it's a secondary data set.
Yes,
It's
ma'am.
fine. Yes, you can do that. Yeah,
Okay.
but do mention
Thank you,
that.
ma'am.
Yes.
Thank you so
Yes,
much.
great. Thank you. Thank you so much. Thanks for sharing this actually. Yeah. The negative correlation still showing high VF. Okay.
So next question we have from Dr. Naseem. If you are there, please ask your question.
Hello, Jasmeet. First of all, I
Hi.
would just like to admire your efforts that you introduced to us this wonderful software, particularly. And I just want to introduce myself. I am an economist and who is actually dealing with more time series and panel data analysis.
Wow. Thank you. Pleasure
But
meeting you, doctor. Yes.
thank you so very much. Actually, Jasmeet, I have always faced a problem. Whenever there is a factor analysis, we always use this term with the cross-sectional data along sometime this
Absolutely.
sort of
Yes.
data. But when we are actually dealing with the panel data analysis and we have to formulate some factors.
Right.
So if I just give you an example that I am working on inclusive growth. And inclusive growth is become a determinant of so many other factors like inequality, then labor productivity, job creation, and so many other variables.
Unemployment.
And I'm
Yes,
dealing,
exactly.
yes. So now I have to build up an index for inclusive growth. So for this, definitely I have to go for PCA so that I can get the commonalities and I can get the weights, and so that I can build an index that can I further use in my analysis. But I just want to know that is that suitable to apply the PCA on this, or should we use some alternative method in order to construct index for panel data analysis?
Yeah, I was coming to that only. Why are you considering PCA only? Why aren't you considering SEM? Structural
Yes,
equation,
because
yeah.
as I told you earlier that I am actually dealing more with time series and panel data analysis, so I'm a bit weak in cross-sectional data. So just gathering the information around me, I just got to know the application of PCA only. So that is why I'm asking a question direct to you, that is there any suitable way? So definitely I'll work on it, that definitely.
Okay, I would advise SEM is better, or factor analysis cannot work because you have a cross-sectional data as well. I would advise you to go ahead with SEM. Let's see how it works out. If not, if you're still facing problems, I believe I'll share my email address as well. If you can just share the data set, maybe we can work it out together and I'll advise you further, if that's workable with you.
Can you please repeat the technique you are saying? It's not clear to
Okay,
sound.
I'm saying, yeah, okay. I am saying if you can check with SEM, structural equation modeling.
Equational modeling. Okay. Thank you.
Yes, it correlates with both the data sets.
Thank you
It
so
can
very much.
work on cross-sectional also. If you face any problems, get back to Dr. Malik or get back to me. Maybe we can help you out with that.
Thank you. Thank you so very much, Jasmeet. Once again, thank you
you.
very much for your
Thank you.
so
Appreciate your
valuable
presence.
presentation.
Thank you. Thank you so much. I appreciate your feedback. Thank you. Okay, we have more queries.
Yeah, ma'am. Dr. Raja wanted to say something. Sir, you want to say something?
No, ma'am. No, no, no. Nothing. Nothing.
Okay. Jaspreet Kaur wanted to ask, I think, a question. Ma'am, if you're there,
Oh, I
please.
can see the questions now. Yes. Okay. Yeah. Can I stop sharing the screen or do you want me to
Yeah,
keep
ma'am, I
sharing?
think that will be
Okay. All right. Great.
Jaspreet Kaur, ma'am, if you're there, please ask.
If we cannot remove heteroskedasticity by transforming the variables, then what can we do? We will do robust regression. Can we do? Yes, you can actually see. Regression is a very beautiful analysis wherein it largely depends on your objectives. If your objectives are very clear, so depending on your objectives, you can decide your dependent variable. So maybe sometimes, like I mentioned, in the last analysis that we did, I mentioned we can cross that. We can make dependent as independent and independent as dependent. If you can do that with your objectives, then you can go ahead with many equations in regression analysis. So as it is, that has to be more than two independent variables. So that means you already have three regression analysis. Once that you are already doing, other two can be take one independent as your dependent factor. You will find somewhere or the other they can also be regressed very highly. So depending on your objective of the research, you can definitely do that. Instead of ignoring it, you can change your objective. Or you can just, play around with the numbers. You can do that. Yes, absolutely. Do not corrupt the data set, but keep changing the equation. That is possible.
Any more questions?
Anyone, any other doubts? I am always available.
Looks like there are no more questions, ma'am. So, would you like to say anything else apart from that, or ma'am?
Yes, absolutely. So it is wonderful to see such a huge, I would say, group of scholars. So please do not use corrupted data sets. It's, the sovereignty of the future growth of data and everything is in our hands. So please try and find out some more data resources and everything. If you're not able to find out anything, get back to us. We are almost 100 plus people here. We can always help out. There's always a solution to a corrupted data. Do not work on corrupted data sets. It will give you wrong interpretations. And if you're putting in wrong interpretations in your papers, it will be published. And, that creates a very, the entire system goes incorrect, like what is happening with the climate change module these days. So please, I would appreciate if all of you are taking care of how you are downloading your data sets and recheck with your data sets. Least corrupted data sets are the best ones to be used. Okay. If you're not able to find the perfect resources, get back to us. We'll help you out with that. Okay. I will just, yeah, I can actually, may I, Dr. Malik, can I give my email address here, or will Shivangi share the presentation?
Yes, please, you can share your email ID, and
Okay. Okay.
while Shivangi can also, give a vote of thank you, then I can
Yeah.
fine.
So, ma'am, just drop your mail ID, then we'll start with a vote of thanks. And I hope there are
Absolutely.
no questions and everyone is very happy with the session.
Thank you, thank you, thank you, everyone. Yes, this
That's
is
all.
my email ID. Okay, my email address is there, and good to see. Thank you, Dr. Malik. Thank you, Shivangi, for your time as well.
So, on behalf of everyone participating in this workshop, I extend my heartfelt thanks to Jasmeet
Thank you.
and for her outstanding presentation on regression analysis through JAS. Her comprehensive approach to these critical topics was nothing short of enlightening. And ma'am's deep expertise paired with her ability to simplify complex concepts provided invaluable insight for researchers and
Thank you.
professionals alike. And not just
Thank
that,
you so much.
her seamless integration of statistical tools like JAS with practical application truly underscored her proficiency in the field of data analytics and econometrics. We are
Thank you. Thank you so
truly
much.
privileged, ma'am, to have benefited from your knowledge and innovative teaching.
I appreciate it.
And
Thank you so
on
much.
behalf of entire organizing committee, once again, I would like to, I would like to express our sincere gratitude for your inspiring contribution and for your time, ma'am.
I appreciate. Thank you. Thank you so much, everyone. All the best ahead. We are all here to help. Thank you. Thank you, Dr. Malik.
Thank you, sir.
Thank you very much. Let me add some lines.
Okay.
So,
yes, please.
On behalf of Jammu and Kashmir Economic Association, General Center for Global South, we are fortunate to complete our 4th day today. We are very grateful for the insightful session you conducted on the popular terms like multicollinearity, heteroskedasticity, and you have shown your expertise as one of the leading, I can say, female econometrician. Truly brought a unique perspective. It was enriching, and our understanding of these important concepts in econometrics. And it was quite engaging discussion. And the clarity you provided have left a lasting impact on all of us. Thank you for sharing your knowledge, inspiring us to delve deeper into econometrics, where we are lacking, female econometricians. Let me highlight again. So we hope to have pleasure of learning from you again and again. So now I request, let me stop.